Somewhere between a surgical tool and a death sentence, these 10 plants built and ended empires. They were in the operating rooms of ancient Greece, the war strategies of medieval Europe, and the religious ceremonies of indigenous cultures across 3 continents. Not because people were reckless, because the chemistry actually worked. The same compound that killed you in a large dose sedated you in a small one. That's not magic, that's pharmacology. And our ancestors figured it out through a method that cost a lot of lives. Let's look at what they actually learned. Before we move on, please take a moment to subscribe to the channel and like the video. Number 1, deadly nightshade. Roman physicians used Atropa belladonna before surgery because atropine, the alkaloid inside it, genuinely blocks the nerve signals that cause muscle spasms and pain. Not folklore. That's a mechanism we still use in operating rooms today. The problem was dosing. No syringe, no milligram scale, no standard reference. A healer working from memory and dried plant material could easily cross the line between sedation and respiratory failure, and many patients did. The plant's name, Atropa, comes from Atropos, the Greek fate who cuts the thread of life. Italian noblewomen in the Renaissance used diluted belladonna extract as eye drops because atropine dilates pupils, and wide pupils were fashionable. Blurred vision lasted for hours. They called it belladonna, beautiful woman, because the look worked, not because anyone understood why. Atropine still sits on the World Health Organization's list of essential medicines. The plant didn't change. We just finally learned to measure it. Number 2, mandrake. Before ether, before chloroform, surgeons in ancient Greece and medieval Europe cut into fully conscious people. Mandragora officinarum, the mandrake, was the one plant that offered a real alternative, and the practitioners who knew how to use it correctly held serious power. The root contains hyoscyamine, scopolamine, and atropine, and when prepared as a wine infusion, that combination could sedate a patient deeply enough to amputate a limb. Medieval surgeons soaked a cloth in mandrake extract mixed with opium and henbane and held it over the patient's nose. That formula spread independently across Arab, Byzantine, and European medical traditions, which tells you the chemistry worked even when the theory behind it didn't. Now the screaming root myth, the ritual harvesting with a dog, the demonic associations, none of that was random. It restricted access. It kept the dosing knowledge inside a small circle of practitioners who understood that a slightly larger preparation didn't sedate the patient. It killed them. Number 3, henbane. Historians wrote off the Oracle of Delphi as theater for a long time. Then archaeologists found the chemical evidence, and one of the plants in the picture was Hyoscyamus niger henbane, a common weed that produces one of the most potent hallucinogenic alkaloids in the plant kingdom. Hyoscyamin, the primary alkaloid, blocks acetylcholine receptors in the areas of the brain that regulate fear, memory, and sensory filtering. When those filters drop, ordinary stimuli feel overwhelming, and from the outside, that looks exactly like a trance or a frenzy. That's why the same compound turned up in religious ritual and on the battlefield. It wasn't 2 different effects. It was one neurological mechanism being used in 2 different settings. The therapeutic window between a useful dose and a fatal one was narrow enough that practitioners needed years of dedicated, risky experience just to survive their own profession. Number 4, Jimson weed, datura. In 1676, British soldiers boiling Jimson weed leaves for a salad started one of the most well-documented poisoning cases in colonial history. They had no idea what datrostramonium was. Within hours, one soldier sat blowing feathers into the air, another tried to kiss everyone nearby, and a third crouched naked in a corner, grinning at nothing. Robert Beverly documented the whole episode in 1705, describing it as a very pleasant comedy. They stayed incapacitated for 11 days and woke up remembering none of it. That amnesia isn't a side effect. It's scopolamine doing exactly what it does, blocking the brain from forming new memories during the intoxication period. You don't remember being sick. The time just disappears. Indigenous practitioners across the Americas used datura carefully, with experienced specialists controlling every dose. The soldiers had none of that knowledge, and datura stramonium is still sending people to emergency rooms for the same reason today. Number 5, hemlock. Most people picture the death of Socrates as something fast and brutal. Plato's account in the Phaedo tells a completely different story. Conium maculatum, hemlock, kills through a rising paralysis that starts at the feet and moves upward. The alkaloid coniine blocks the receptors at the neuromuscular junction, so muscles stop responding to nerve signals from the bottom up. Socrates' legs went numb first, then his torso, and he kept talking with his friends right up until his breathing stopped. The brain stays intact the whole time. It's a motor shutdown, not a cognitive one. Athens chose hemlock deliberately as a civic execution method because it produced a predictable, observable sequence that fit their cultural idea of a dignified death. Someone had studied this plant carefully enough to build a formal protocol around it. And that same compound, in smaller doses, Greek physicians used as a muscle relaxant. Number 6, yew tree. Everyone knows the English longbow won at Agincourt. What doesn't get mentioned is that Taxus baccata, the yew tree, is one of the most toxic plants in Europe. And the archers spending their careers handling that wood were working with material that could kill them through any open cut in their skin. Taxine alkaloids disrupt the calcium and sodium channels in cardiac muscle cells, which knocks the heart's electrical rhythm out completely. There's no antidote. Yew poisoning today is fast and almost always fatal if enough plant material gets ingested. Medieval people knew this well enough to plant yew in churchyards specifically to keep livestock away from graves. In the 1960s, researchers isolated paclitaxel from the Pacific yew, Taxus brevifolia, and it's now one of the most widely used chemotherapy drugs in the world, freezing cancer cell division at the molecular level. Number 7, opium poppy. Papaver somniferum has been cultivated for at least 6,000 years. Sumerian clay tablets call it the joy plant. Egyptian physicians used it for pain and to quiet crying children. That's not primitive guesswork. That's a functional medical technology predating most modern civilizations. Morphine binds to opioid receptors in the brain and spinal cord, blocking pain while producing a strong sense of well-being. Before opium, surgeons had almost nothing that managed severe pain reliably. The problem is that the same receptor binding that stops pain also builds physical dependence, and a high enough dose stops the brain from signaling the lungs to breathe. Britain went to war twice in the 1800s to keep selling Indian opium into China after China tried to ban it. Tens of millions of Chinese people were addicted at the peak of that trade, and the chemistry hadn't changed at all. Number 8, wolfsbane, aconite. Aconitum, wolfsbane, is the most acutely toxic plant in the European flora. A few milligrams of aconitine is enough to kill an adult, and ancient hunters across Europe, Asia, and the Arctic used that fact deliberately, tipping arrows with it to bring down large game fast enough that the animal couldn't travel far before collapsing. Aconitine holds sodium channels open in nerve and cardiac cells, so the heart can't maintain its rhythm. Tingling comes first, then numbness, then arrhythmia. The Ainu people of Japan passed the preparation of aconitine-tipped arrows through specific family lines, because getting it wrong didn't just mean a bad hunt. There's no antidote today. Modern medicine manages the symptoms and waits. Traditional Chinese and Ayurvedic practitioners processed aconitum through prolonged boiling because heat converts aconitine into less toxic compounds, and they almost certainly learned that by watching what happened when they skipped it. Number 9, strangler fig. Every other plant in this list will hurt you fast. The strangler fig takes decades, and that's exactly what made it so unsettling to the cultures that lived alongside it. A bird drops a seed in the canopy of another tree. The fig sprouts, sends roots down toward the soil, and slowly wraps a lattice of roots around the host trunk. The host tree rots away inside, and what's left standing is a hollow root structure shaped perfectly like whatever it consumed. At Ta Prohm in Angkor, Cambodia, Strangler figs have been splitting apart stone walls that survived centuries of weather. The Khmer Empire built those temples. The figs are quietly taking them apart. Ecologically, it's a smart strategy. The fig starts where the light is, builds its own support structure using the host as scaffolding, and once that root cage closes, the host simply becomes irrelevant. Number 10. Poison ivy. Toxicodendron radicans doesn't stop your heart or cause hallucinations. What it does is coat your skin with urushiol, an oily resin that triggers a blistering immune response in roughly 85% of people who touch it, and the reaction takes 12 to 72 hours to show up, so most people never connect the rash to the plant. Indigenous peoples of Eastern North America knew exactly what poison ivy was, how to identify it, how to avoid it, and in some cases, how to use it medicinally. European colonists arrived without any of that knowledge and paid for it repeatedly. Workers clearing forests during colonial-era land clearing burned vegetation without knowing what they'd torched, and urushiol particles in smoke caused respiratory reactions and full-body rashes. The oil stays active on tools and clothing for years. First exposure sensitizes you, and repeated contact tends to make the reaction worse, not better. None of these plants changed. The atropine in belladonna was always going to block those nerve receptors. Morphine was always going to bind those opioid sites. Urushiol was always going to trigger that immune response. The chemistry didn't shift. Our ability to measure it did.